an object. Um, and that's probably like the main thing that you should know. So for example, if you like you see here, um, this is a class and it lays out the blueprint um, for the object. So if you look over here, sorry, this is the class. It has the variable, or it shows x is equal to 5. And if we go over here, we can set p1, an object, to our class, my class, and it will print, and then we can print p1.x, which will give us 5 because since p1 is our class and we want to print out the x value from my class, it'll just print out 5. Next, we'll go over the init function. So the init function basically just initializes the class. So if we look over here, we have the class here and we initialize it with our self, name, and our age. So when over here, under we use the things that we called over here, our self, name, and age, where we set self dot name to our name, to whatever is here, and the age of self to age over here. So this self dot name isn't actually referring to this. It's referring to it's referring to what is considered, like, it's a whole different variable on its own. You can consider it its own variable essentially. So what we do after is we, of course, like we did before, we give the class, make it equal to an object. So we assign this class person to our object p1. And then we print p1.name, and we'll get whatever we put in our name. Here we put John. So this would print out John. And it would do the exact same thing for print p1.age, because if you think about it, self is referring to p1. So if we were to print out self, which is p1.age, then we would get whatever age we put in this case 36. So self essentially just refers to whatever whatever object that you assigned the class to. So if you want to call self.age in this case, we would have to put p1.age because that's the object that we assigned the class to. The string function, or str function, is basically it will represent the object as a string. So, or it will represent like a certain portion, like a certain thing as a string. It'll make a bit of sense later. So we do this exact same thing that we did last time, where we assign our class, we initialize it with these 3, and then we set some variables. We have our object, and we set it to a class, and then we print it. If we look over here, however, there's one main difference where we use the str function, where if we like we said, self is referring to p1. So here, when we're here in this part of the class, we're returning self.name and self.age. So if we look at it, if we try it over here, this might be a bit confusing, but it'll return John 36 because what we're having here is our self name and then in parentheses our age. So it'll essentially have our name over here and then our age over here in parentheses because there's parentheses over here. Also, when you're using this thing, make sure that you put your like when you're calling self.name, self.age, whatever you call, make sure that you're putting them in curly brackets, or else it'll just print self.name instead of what you want. So next we'll go over object methods, which are basically just, I mean, like it says, it's methods for objects. Um, so we do the same thing like usual. We have, we initialize it, self, name, age, all the same thing. Then we have here, we define a function with self. And when you call this function for this class, it'll do whatever it says here. So in this case, we're printing, hello, my name is self.name. So we assign it to a class, and then here we call p1, which, as we know, is assigned to class.person, and we call my function that's within the class. So it would go to here and print, hello, my name is whatever self.name is, in which case, in this case, it's John. So here it would print out, hello, my name is John. I've already kind of explained this, but the self parameter, it essentially just goes into, like here it just goes into like what self means. Like we said, it's basically just whatever p1 or whatever you assign the class to in this instance. If we were to assign this class to a different one, say p2, in order to call that class, you would have to do p2 dot whatever you use, because we're assigning that class to a different one, not p1. So self is just a way to just write over here what, like here, to use self dot name to assign it to a thing, because you don't know what object you're going to assign it to once you actually like attribute the class to an object. Also, it doesn't have to be named self. You can name it whatever you want, just as long as it's the first parameter. It's probably best to use self because it's just a good habit to get into, unless you want to use something else, in which case you should probably try and keep it consistent. Like whatever you choose, just try and keep it consistent throughout like the whatever whatever projects that you're doing. So if you for some reason want to use my silly object for your classes, just try and make that consistent so that you don't end up like, so it's not something that you have to be wary of every single time that you look at your class or your functions in your classes or your objects. Okay. Just like variables, you're also able to modify the properties of the object using like you usually would a variable. So if we were to assume that we do basically the same thing here, we assign my silly object.age to whatever age we have. So here it would assign age, or my silly object.age, to 36. But we're allowed to change that to 40 here, just by doing it exactly like this. Also, if you just put age equals 40, that wouldn't work because you need to specify that it's on the P1 object and the age property of the P1 object. Something to note is that it's not going to change, like if you assign P1 to the class, and then like let's say you assign P1 to person John 36, and then let's say you well, okay, I mean I should probably show it, but so as you can see, if we were to put this over here, it would print 36, because see it prints 36 first and then 40, because we assigned it to 36 originally. So when we print it here, it stays at 36. But once we change the age property to 40, when you print it again, it becomes 40. However, if we were to say assign P2 equal to person, and then let's just choose a different one like Jane and 42. And then we wanted to print the age of P2.age. If we want to print the age of the second person, it shouldn't change. So if the changing P1's age to 40 doesn't change the class for any other object or the class itself. It'll just do it specifically for P1, specifically the age property of P1 and nothing else. You can also delete object properties in case you don't want them. This is pretty straightforward. You just put del and then P1 and del and then the property that you want afterwards. And it'll essentially just get rid of that property if say you don't want if you don't want a parameter going forward, or if you just or if it's going to mess up your program moving forward, then you're just allowed to delete the age property entirely and you won't have to deal with it anymore. You can also delete objects in case, I mean, like I said, if the object is going to cause problems moving forward in your code, or you don't really know what you're going to do with the object, or it's just taking up space, you're allowed to just delete that object as well. It won't delete the class that the object is assigned to. It'll just delete the object itself. So if you've assigned the class to a different object, then it won't delete the class. It'll just delete that specific object P1. Past statement's just the same. We already learned this. You can do the same thing with the class. That's straightforward. Okay, I guess we would do this. Okay. So if anyone knows the answers to this, just show it. Yeah, if you guys know the answer to this question, type it out. Okay, well, I mean, here it's just in order to create a class, you have to use the word class. So yeah, the word class is used to initialize the class, and here it's just that. Next, create an object of my class called P1. So you want to create an object, use it, and assign it to this class. So, I mean, if you guys know the answer, feel free to say it. For this one, it's pretty simple. You just assign P1 to the class like you would a variable. Oops, I should have had it a little bit earlier, but yeah, I'm sorry. If you want it again, here it is. Oops. Because we're assigning P1 to my class. Here, use the P1 object to print the value of X. So what we would do here is we want to print we want to have P1. We want to find the value of X specifically for P1. I mean, it doesn't matter whatever thing we did, but we want it specifically for P1 here. So here what we would do is pretty simple. We just call the X property of P1. And in order to do that, we just say the variable and then dot whatever property we want from it. And then here it's also pretty simple. It's just the init function. Okay, we'll go over inheritance. Next we'll go over inheritance. This one's pretty straightforward. So there's two types of classes. There's the parent class and then the child classes. So basically, if you just have any class that's going to be considered your parent class. So for example, here, this is considered a parent class. And then pass. And a child class is basically a class that takes that's inside the first class or inside the parent class, and anything that the parent class, any property, anything that the parent class has, will also be in like it says inherited into the child class, just like a gene would, or like a specific trait. So like, if actually that's not a good example. But yeah. Basically anything is pretty straightforward. Anything that the parent class has, the child class will also have. If you want to initialize a child class, you print class, and then the name of your child class, and then in parentheses next to it, you want the parent class, because any class that you put here will also be all the properties will be inherited by this new class. So if we were to get this, we don't even have to, let's say you just wanted a student class that was exactly the same as the person class. So here, you don't even have to write anything. You can just write, well, you'd have to write pass because you can't have nothing inside there, but you can basically just write, you don't have to write anything extra. So you could just go straight to initializing an object with the new child class, and you don't even have to write anything because the parent, it's already inherited all of the functions, all of the properties of the parent class. Over here, it's just the same thing in it. It's basically the same thing. You can do almost the same thing as the parent class. This is important though. Anything that you initialize in your child class will override the parent's whatever they inherited from the parent class. So if you were to have a parent class with that initialized something different from this would take priority, and this would be in the new child class. Okay, I mean, there's a super function, I guess. It'll just inherit if you initialize something, and then you write super, then it'll just take everything from person in this place, and then just copy it, basically copy paste it down there. You don't have to write everything out again. You can add properties. So here what they're doing is they're taking everything from the person class, except they're also adding a graduation year. So now it has all the properties that the person class had, and includes graduation year as well. Um, yeah, it's just showing an example of that. You can also add a method where it's just the same thing, honestly. There's nothing really new here, that much. I guess we could go over iterators. Iterators are basically an object that's able to, like the name says, iterate every value of a list, a tuple, a lot of things. So, for example, here we have a tuple, apple, banana, with apple, banana, and cherry, and we also make a new um, iterator that where it's just we call it by using the iter function, and in parentheses having what the thing we want to iterate. So in this case, we want to iterate my tuple. So we have my tuple in the parentheses of our iterator. Um, this is a bit important, I guess. Um, there's a difference between the word iterator and iterable. Um, basically, the thing that you are iterating is considered an iterable object, and the thing that you're using to iterate those iterable objects are called iterators. So yeah. Um, so if we look at this, right, it'll print apple, banana, and cherry because the iterator is going through each value of your tuple, and it starts with apple over here, banana over here, and then cherry over here. So what it's doing is it's going to the next value first, which is apple, then it goes to the next value, which is banana, and the next value is a cherry. Because, I mean, it says next here. Um, yeah, you can also do this with strings, in which case it would output every single character. So it starts with B, then it goes to A, and then it goes to N, and then A, and so on. And if we were to theoretically just do this one more time. Oh, okay, never mind. You can't go over the amount of characters in here, I guess. So it doesn't repeat, it doesn't go back to the first one. It just ends where it ends. And if you do any more, then it just calls an error. It just shows an error. Um, okay, so as you can see, this is just very long. You don't want to repeat print next my it a million times over, especially if it's a really long string or a really long list. You don't want to just print this a million times. So what you can do is use a for loop and just print um, and then just print the every value of it using a for loop. So for every value in your my tuple, it's printing that value. So for apple in my tuple, print apple. For banana in my tuple, print banana. For cherry in my tuple, you print cherry. And you can also do it with strings. It just goes like the iterator. It goes through each character one by one. Um, you can also create an iterator inside of a class using the iter function, or yeah, using the iter function, and then you can also use You can also use the next function to just like, which is basically the same thing as this. So the iterator function is essentially the same thing as this, and the next function is just the same as this. You can also use a stop iteration statement where it basically, if in here they use it as an if else statement, but at a certain point you can just stop iteration, and it says it is what it says it does. It just stops iterating after it gets to stop iteration statement. So here, it just keeps iterating over here because it just keeps iterating because it has the iter function and the next function. And then once it reaches a certain point, it's just going to, it fulfills this statement and it just stops iterating. It just stops the class, stops the iteration of the class in the class. If anyone has any questions, you can ask. Oh, the reason why it becomes something weird is because you forgot the next. Make sure that you have next so that it knows that you're going to like whatever the next thing is. So when you're printing it, you have to do print next my it. Don't just do my it, or else it's not going to work. It's just going to show an error. Even if you're starting at the first one, you always have to start with next instead of start with next my it instead of just my it. Okay, next we have polymorphism. Okay, this is just. Oh, okay. Well, polymorphism is basically just any function, method, operator where it can just be used in a multitude of situations. So, like for example, the len function can be used on strings, it can be used on tuples, it can be used on dictionaries, it can be used on a lot of things. So you can create your own thing. You can create your own function that is used in multiple different situations, and that's called polymorphism. So, for example, here we define move 3 times in 3 different classes. So we define move in car, we define move in boat, and we define move in plane. And as you can see, every single time they print something different. So for a car, they'll print drive. For a boat, they'll print sail. And for a plane, they'll print fly. But as you can see, well, okay. You could, well, first we initialize our objects to our classes because that's what you're supposed to do. And then for like here we just have a for loop to just go through each of the objects. And every time we call the x.move function of each of the classes. So in the car class, it'll go to move and it'll print drive. In the boat class, it'll go to move and it'll print sail. And in the plane class, it'll go to move and print fly. So it doesn't matter if you have the same function in different classes, as long as like they're not in the same class. That saying x.move shouldn't matter if like they're using different classes. It'll just go specifically into that class and then get the move function from that and use that. So inheritance class polymorphism. Yeah, okay. So this one, it combines inheritance, which we learned like a little bit ago, and polymorphism, where here we have our parent class vehicle, and in our parent class we have a move function, which prints move. And all 3 of these are child classes of this parent class. So here we just pass, which means we just inherit everything from here. So even though it says pass here, since it's a child class of this parent class, it'll inherit everything from here. So basically, this code, you can think of this code as being in this pass. However, here we redefine move. In these 2 places, we redefine move to be sail and fly respectively. And remember, inheritance is of the child class is always going to be like anything newly defined in the child classes will take precedence over, um, or will take priority over what's in here. So these two things will overwrite the move class from here. So if we look over here, since the car class has the exact same thing here, it'll print move. Since these two overwrite the move function from before, it'll print sail and fly. I hope that makes some amount of sense. Yeah. Okay, we'll go over scope next. This one's pretty simple. Basically, any function, any variable that's that's created inside of a function or a class or whatever is going to be specifically inside that function itself. So if we were to, so here, this would work. It just, we define my function, we have x, we print x, and we just call my function. However, if we were to try and print x, yeah, we get an error because outside of this function, no one knows what x is. So x isn't defined outside of this function. So if we call something inside of the function, it's just going to stay within that function. It's like a secret within a group, as long as a group is good at keeping secrets. It's just going to stay within the function and never get out. It's a little different. Well, actually, yeah, let's go back to that. It's a little different if we were to move this out of the function. I think this should work. If we were to move this out of the function and print x here, it'll print x 2 times because this isn't in the function anymore. Since it's not in the function, this print statement knows what x is. It knows it's 300. So it'll be able to print it without giving an error. Yeah, that's what's described here. It's called global scope, where anything that's created outside of a function, outside of like anything, if it's created by itself on its first indent, it will be able to be used inside inside any functions and just in general. So in general, it's good practice to try and keep all of your variables global, but it's not necessary per se. But it's just good practice. Okay, so here, you define 300, x equal to 300 as a global variable. But if inside of a function, you redefine x, this print statement will print 200, and this print statement will print 300, because this x, it's essentially creating 2 copies of x, where here, it changes x to 200. So this print statement knows, oh, x was changed to 200, so it prints 200. However, here, it doesn't know anything that's going on within this function. So it just prints 300 because it doesn't know that x has changed to 200. So it'll just print 300. There's a keyword that you can use, global, which basically just makes any variable inside any local variable global. So this print x won't give an error here because we made x a global variable. So any changes that's done to this global x variable will also happen out here. Yeah, so here it's same thing basically. It goes to 300 and then it makes x global inside of this function. and it changes x to 200. So in this case, in the last one where it was similar to this would have printed 300. But since we made x global inside the function and we changed it to 200, this print statement now knows, oh, it's been changed to 200. So this will print 200. Modules. Okay, well, this is basically just like importing, or not import. Wait, is it importing? Well, basically, this module is just like a library of just like a completely new set of like random functions. Um, so like for example, so to create a module, you name the file your whatever thingy dot whatever module you want to use. So for Python, you add py, so .py. So if you save this to my module.py, right? This my module will become a module. So every time you want to use this function inside of a different thing, you just import my module into the new file, and you can use my modules. You can use greeting from my module because you imported it into a different place. You can also do the same with the like dictionaries, variables. If as long as you import them, anything that comes in here will essentially just like think of everything in every line of code in in my module is just being written over here shorthand as to import my module. And anything that's used in here can also be used outside of it. You can name a module whatever you want. Just add .py when you're using Python. I think it changes if you're using different coding languages, but here we just need to worry about Python. So it's .py. Make sure to remember that, .py. If you want to rename a module, you can import it and add the as something function, because this will just make every instance of mx basically be the same as my module. So now you're able to do this without making any errors. There's some built-in modules. Some we're going to come across very soon. So platform is an example of them. There's the dir function. Wait, yeah. Okay, this is kind of important. So the dir function, I think, refers to like all the things inside of platform, like all of the, how do I describe this? Basically everything that's inside of platform. You can I think it's shorthand for directory. So it'll print all the names over here. It'll just print all the names in the directory of platform. Okay. So if we have here, we have my module, and like just stuff here. Here from my module we import specifically just this. So instead of importing all of my module, which would have given everything here, we only import this specific part of it, and we print age. If we were to try and use greeting, I don't think it works because we haven't imported this specific part of it. So if we were to try to put greeting and a name, it would just print an error because this file doesn't know what this is because we haven't imported that specific part from my module. We've only imported person1, the dictionary. I think the next three parts are just like three different like important specific important like modules. This one's just date and time. You import using import date time, and using this, it'll show the current date. There's a bunch of like different functions in here. Um, yeah, there's nothing too important. Just know that like this is the way to, if you want to have a date or a time inside of your like project, you have to import it using date time. So you can think of date time as kind of being a dictionary where it at like every single microsecond it checks what is the year, what is the month, what is the day, what is the hour, and so on, where it just updates every single microsecond because it does go down all the way to the microsecond as shown here. um yeah, it's you can create an object with it. Here you just import a date, and you import the date of 5/17/2020 into this object, and then this will just print 5/17/2020, or I guess in this case 2025/17, because that's the order that you do it for date times. um you start with year, then you go to your month, and then your day, and then it'll print 2025/17 here. I guess, yeah, it also takes into account time zones, but you don't really need to use them all the time. This is just showing the name of the month. Nothing really that important. Here's a bunch of the like functions. It's quite a bit to go over, so I don't think I'll be able to go over them, like any of them. If you want, you can try and find this and like look at them yourself, but I don't really have time to explain all of these. This one's pretty important. The math module. Um, there's some built-in math functions. You've already encountered some of them, min and max, which basically just takes the minimum of a certain amount of values and the maximum of a certain amount of values. The absolute value function just takes the absolute value of whatever's inside the parentheses. The pow function is basically the exponential function. So here we're doing pow for 3. So here it's showing 4 to the third. So x is equal to 4 to the third. This would just print 4 to the third, which would be 64. Yeah. If you want more math functions than those 3, though, you can import the math module, and it gives you a lot more to work with. So here you can use the square root. You can get the ceiling and floor, which basically, if you don't know what that is, the ceiling is just the highest integer of whatever number that you put in here. Floor is just the lowest integer, or sorry, is the next integer down. So here, if we round to the nearest integer up, then we will get 2. And in here, if we round to the nearest integer down, we get 1. There's also just pi, literally just pi. There's a lot more. I think this has a bunch of them. Yeah, you can just there's a lot. So once again, if you we don't have time to go over all of them. So just if you can find it, you can look at that yourself. And then this one is another module. It's the JSON. JSON is a completely different coding language. It's related to JavaScript actually, or Java and JavaScript, but you're allowed to import the module of JSON into here, and you're able to parse things in JSON and convert them into Python, or alternatively, you can convert them from Python to JSON. This isn't too important, I think, but you should still know it. There might be some important. This might be some good stuff that you could do with it. Um, yeah. Um, these are the things that you can. These are the objects, Python objects that you can convert into JSON, and yeah, there's an example of each of them over here. This is basically the Python equivalent of each JSON or JSON equivalent of each Python object, whichever way you want to see it. We've gone over arrays and lists before. Tuples are also arrays in JSON. str is for string, integer is a number, float is also a number, true, false, and then none becomes null. That's not really that important, but yeah. So here, hold on. Yeah, okay. So here we're basically just converting this Python into a JSON. So it's JSON is an object-oriented language, which basically means that it. Oh, sorry, I didn't look at the questions. Sorry about that. Yeah, so here we have Python code here, and then we dump it into a JSON. We convert it into a JSON. Pretty simple. That's JSON.dumps, and JSON.loads is really the important stuff here to convert from Python to JSON and vice versa. This isn't super important, but you're able to format how the JSON would look in code. So if we go over here, we have this Python code over here, and then we convert it into a JSON. But you can add additional parameters to your JSON where you can have the amount of indent that you have and your separators. So basically a separator shows when you have like a new line. So for example, we have comma as a separator, comma space as a separator here. And we have a comma space here. And as you can see, it creates a new line once we get to BMW 230. It goes to new line, goes to MPG. As you can see, this is what JSON looks like. If you didn't know. Yeah, nothing really big to go over there. If you want to learn JSON on your own time, that's like by all means, that's probably a good idea. I don't know that much JSON, but yeah. You can also sort your things. So here, as you can see, we have name, age, married, divorced. You're able to order these in alphabetical order. So as you can see, we start with age, A, first letter of the alphabet. Then we go to cars, C, and then children, and then divorced, married, name, pets. It also sorts whatever's inside here. So if we were to change this to Billy and Anne, this should change it to Anne and Billy. Oh, never mind. Okay. Oh, I thought that it would. Okay, never mind. That doesn't sort. So it only sorts the outside bits here. So name, age, married, anything that's inside here, it will not sort. Hold on, give me a second, sorry. Okay. This is probably the last thing that's gonna be in the lecture today. We're gonna learn about I think it's pronounced regex. It's basically a way to, well, it's a new module, first of all. but it's a way to write different strings into like specific expressions. So, for example, we have the rain in Spain. Well, okay. First of all, it's imported using RE. Um, I don't know if it's referring to the RE in the read in the REG part, or if it's referring to the R and E. But either way, you import it using RE. So let's say you have this text, right? If you want to search for this specific string, well, I'll explain what this means in a second. But if you want to find this specific string inside of your text, as like there's text here, you write re.search, and you put your string that you want to find, and then you put your whatever like thing that you want to check it in. Find all, you return a list with all matches, and yeah, there's okay. So as you can see, this looks kind of weird. There's like random symbols in the middle of these. Those are called meta characters, where I mean these are characters that you're looking for. So if I don't think I can really like go through each of them in detail, but what we will do is we'll look at this and then try and figure out what this is saying. So first we want to have, so first thing that we see is this symbol, which corresponds to this symbol. So we want to have it start with the word, with the. And then we want any character. So that could, in this case, it would be referring to rain in, including the spaces, because spaces also are considered characters. You want any character with 0 or more occurrences, because there's an asterisk. So we want any character for 0 or more occurrences, and in which case that's satisfied because we have rain in. All of these are considered characters. Also, the period doesn't count a new line. New lines don't count as a character. And then we also want, so the $ means ends with. So we want it to end with Spain. And as you can see, it does here. So we want to start with the, we want any amount of random characters in between, and we want it to end with Spain. As you can see, the rain in Spain works here because it starts with the, it has a certain amount of characters in between, and it ends with Spain. So this would, if you searched it here, this would be returned from this function. There's some special sequences. Again, I can't really go over all of them. It's too many. Just go over one by one. But you can look at this for a little bit. Okay, so if you look over here, we have any character from your dot. But if you want to have a specific set of characters, then you can put it inside of square brackets. So, yeah, if over here we were to replace this with square brackets and put like A, then this wouldn't work anymore because R space and basically any of these characters aren't in the set A, and it wouldn't count here because yeah. So here it just returns where A, R, or N is present. You can also do this with numbers. You can do it with symbols. You can do it with capital and lowercase letters. There's a lot of stuff you can do with this. I'll leave this up for like a little bit if you want to look at it. There's a find all function where you just look for every instance of a certain string in your text. So we have AI, so there'd be an AI here and an AI here, so it would print those. If there's no If the string isn't found in anywhere, then it's just going to return an empty list. So Portugal is not in the rain in Spain, so it would return an empty list. The search function, we saw it before. It just shows basically, like it just checks for this specific thing in here. Also, note that this is, I think it's a special sequence. Returns a match where the string contains a white space character. So yeah, beware if there's a backslash in general, just be wary of it because it's probably going to be a special sequence. Again, if no matches are found, then it's just going to return nothing. Split function, it's just a list where it's just split at every single instance of the string. There's also a special parameter, an extra optional parameter you can use, which is like how many splits, the maximum number of splits that you want. There's this sub function where every single instance of this string is replaced with whatever you have here. And you can limit the number of replacements with the optional parameter at the end. So this one, yeah. There's the match object. It's an object that contains information about basically whatever's happening in here. And in this case, this will print an object, match object. The match object has multiple methods. Span returns a tuple with the start and end positions of the match. String returns the string passed into function. Group returns the part of the string where there was a match. This is just a garbled mess of stuff. And here is just span, string, group. They're not super important. I mean, yeah, they're not that important, but it's probably good to just like review it just in case you don't know. And make sure that you like at least know some of like the meta characters and the special sequences because they're probably going to come up at some point. I haven't used them that often, but I wouldn't be surprised if they have it in like a a competition or something. But yeah. Um Sorry, give me 1 second. I'll put the meta characters and special sequences inside of the lecture notes so that you guys have easy access to them. Um, have you guys had any difficulty with any of the coding bat problems that you've had? Um, if so, you can like put them in question and answer. But I just want to make sure that there was nothing that was hard. If you have any questions about it, you can ask me. We can go over them. Um, yeah. Uh, like in list one, string one to string two, logic one, logic two, if you've had any like problems in those areas. Um, okay. If not, it doesn't seem like there's any questions, so we'll just go through list two real quick. Um, so we'll start with count evens. Return the number of even integers in the given array. Note that the mod operator computes the remainder. So 5 mod 2 is 1. We've already gone over this a little before. So I'll give you guys a few minutes to try out this problem for yourselves, and I'll give you guys the answer in a little bit. Okay, so I'll go over the answer for this one now. So for this one, since we want to count the number of even ints, first we'll initialize a variable that keeps track of how many even numbers that we have, and then for every element, for every single value in our list, we want to check if they're even. And a good way to do that is to just do our number mod 2, because if it's even, then it's gonna be equal to 0, and if it's odd, it's gonna be equal to 1. So if it's equal to 0, we want to increase our count by 1. And all we have to do after that is just return our count value. Yeah. I'll leave this up here for a little bit so you guys can check it. We'll also be having a little detour real quick to going all the way back to string because someone had a question about those. So yeah. String to and other. Okay, so given two strings, return true if either of the strings appears at the very end of the other string, ignoring upper lowercase differences. So basically, we just want to check if one of our strings is at the end of the other string. It doesn't matter which way around it is, and it also doesn't matter whether it's uppercase or lowercase, as long as they're the same, like as long as they're the same letter. Um, so for this one, what we can do is first we'll initialize some variables, um, where we're basically just gonna change them to their to the lowercase values of each of them, because if we do that, then it doesn't matter whether they're uppercase or lowercase. All that matters is whether that's the letter or not. So here it will just make ABC, but all of them would be lowercase, and here it would also be ABC, but all of them are lowercase. And that's important because when we're comparing them, it's case specific. So if there is an uppercase value, if there's an uppercase B instead of a lowercase b, it won't count. So, or at least to the code, it won't count. To the program, it won't count, even though we want it to count. So by changing both of them to the lower values, whether it's uppercase or lowercase, it doesn't matter, even though it's even if it's case specific. So what we'll do now is we'll just return our a value, or we want to have the part of the string that's length b to the start of, because as you know, if we have a negative number at the start, it counts backwards from the end of our string. So by having negative length b, we go however long b is, that amount away from the end of a, all the way to the end of a, in order to check whether that's equal to our actual string. And then since it can do it for we can have b at the end of a or a at the end of b, we do the exact same thing, but with our values switched around. So instead of a with length b, or going back length b, we have b going back length a, all the way to the end. And we have to make sure that's equal to a. So this should work. Yep. If you have any questions about this, or you want me to clarify something, just tell me. I'm not exactly sure what you mean by repeat it. Because I mean this is and other. So there's also a different way that you could do this. There's a very specific method that you can use called the ends with function. This is this is a very efficient way to do it. The reason why I didn't show it before is because well, hold on, sorry. This needs to be like that. The reason why I didn't show it before is because you also need to know how to do this. This is also very important to know. Both of these are pretty important to know, actually. So yeah, doesn't really matter which way you do it. Both are good ways. Both are completely fine. Um, if there's not really any other questions, I'll move on to um, this one. Big diff. Given an array one or more ints, return the difference between the largest and smallest value of the array. And then note that the built-in min and max functions return the smaller or larger of two values. So we want given that a certain amount of given an array with a certain amount of integers, we want to find the biggest one and we want to find the smallest one and we want to find the difference between them. If you know what a range is in like statistics, it's basically just the range of the array. So I'll give you guys like a few minutes to try out this one. Okay, I'll start to go over this one. So for this one's pretty simple. We all we have to do is just return, return the maximum of our array, and we just want to minus the minimum of the array because even though here it has minimum of two separate values, we can also just put the maximum of an array and it'll give us the maximum number. So if we just do max of this array, it'll give us 10. And if we do the minimum of this array, we'll get 3. So all we have to do is just do the max of the array minus the minimum of the array, and we'll get, because that's the largest and smallest values in the array, that's just what they want. So it's a pretty straightforward one this time. And we'll go on to the next one now. Centered average, return the centered average of an array of ints, which we'll say is the mean average of the values except ignoring the largest and smallest values in the array. If there are multiple copies of the smallest value, ignore just one copy, and likewise for the largest value. Use int division to produce the final average. You may assume that the array is length 3 or more. So basically, you want to find the average of an array, but you're taking away the biggest number and the smallest number. So here we're only taking the average of 2, 3, 4 because we're taking away 1, which is the smallest number, and 100, which is the biggest number. It also doesn't matter which order they're in. Here we would take out 10, and we would take out 1 here. Also, we would only take out one of the ones because we're taking out this one of the smallest values. So this one would still be considered in the centered average. I'll give you guys a little bit to try out this problem as well. Okay, we'll start to go over this one. Sorry if I'm going on a little fast, but yeah. So what we want to do here, first we'll have a variable which is just equal to our sum. We'll keep it at 0 for now. So for every element in our array, we want to have we want to make it, we just want to add, or for now we'll just get the sum of every single element inside of the array. So here we'll give our sum, and then what we can do after is just return our sum. But since we don't want our largest value and our smallest value, or our smallest value, what we can do is we can just take out the smallest value, and we can also take out the largest value from our sums. And then of course, we also need to divide it by, like, since it's an average and not a sum, we also have to divide by the number in the middle. So what we can do is we can divide it by the length of the nums, the length of the array nums, but minus 2. Because since we're taking away this one and this one, we only have to worry about this one, so we're taking away 2. Oopsie. What have I messed up? Is there an extra parentheses here? Okay, what have I messed up? I think I just have this wrong somewhere. Hold on. This should work. What? Okay, I think it's something to do. I think it's some parentheses mess. Let me figure this out. Yeah, okay, there you go. Yeah, I just messed up my parentheses. Yeah, but this is how you do it, like that. We'll go to the next one. Sum 13. Return the sum of the numbers in the array, returning 0 for an empty array. Except the number 13 is very unlucky, so it does not count, and numbers that come immediately after 13 also do not count. We've had a question like this before, but now we have extra parameters. So if we have a 13, um, the number 13 and the number that comes right after 13 doesn't count. So if we have 1, 13, 2, and 1, the 13 and 2 wouldn't count. So we would just have 1 and 1 and sum that equals 2. Also, if oh wait, no, never mind. If there's nothing that's inputted, if the array is empty, then you just return 0. So I'll give you guys a bit to do this one, and then yeah, we'll go over it in a sec. Okay, we'll go over this one now. So for this one, um, so we'll first check if the array is empty. So we can do that easily. We want to check if the length of it is 0, because if it is 0, we just want to return 0. So once we've checked for that, now we can we can just get the sum of it with we using our parameters. So for I in range, so for every element in the range 0 to, okay, we can just do this, I think. The length of our array. We can check if the number is equal to 13. And if it is, then we can change it to 0. And so basically, if the number is 13, we change it to 0 so it doesn't count towards our sum. And then we can check if the one after, if the one after is less than the length of our number, because if 13 is our last number, then if we just use I plus 1 by itself, then it's going to return error. So we want to check first if I plus 1 is actually within the length of the array. And if it is, then, oops, wait, I forgot this. If it is, then we can just change that one as well into 0. So it doesn't count towards our sum. And then lastly, we can just return the sum of our array. Oopsie, what have I messed up? Um, um, honestly, I'm not sure what I think it's this. These are supposed to be square brackets. Yeah, okay. So yeah. We check if it's 0, then for every number, we check if it's 13. If it is, then we make that number 0. We check if the number after that is within the range of our array. If it is, then we change that to 0 as well, so that these two don't count towards our sums. And then we just take the sum of the rest of the numbers, or technically all of the numbers, but 13 and the one after don't count. Okay, next one, sum 67. Return the sum of the numbers in the array, except ignore sections of numbers starting with a 6 and extending to the next 7. Every 6 will be followed by at least one 7. Return 0 for no numbers. So basically, any numbers between a 6 and a 7 don't count. So here we have 6, 99, 99, 7. These 99s don't count because the 6 is over here, 7's over here. So anything in between those two don't count. So these 92s don't count. These 1, 2, and 2 don't count. Also, the 6 and the 7 themselves don't count either. Also, if the array is empty, then just return 0. So I'll give you guys a bit to try out this one. Okay, we will start going over this problem. Um, so yeah, first, what we'll do here is um, for every element in the range of the length of the array, what we want to do is we want to check if the number is 6. So if the number is equal to 6, so 6. If it is equal to 6, then we make that number equal to 0 so it doesn't count towards the sum. And then for every element in the every element in the range of that number plus 1, all the way to the length of our array. We'll just call another variable temp, I guess, for that number. That one is going to be equal to, we're just going to make everything that comes after the 6 equal to 0, except for once we reach a 7. So if temp is equal to 0, or sorry, not 0, 7, we want to make I equal to j plus 1, and then we break it. So basically what this does is so if we reach a 6, we make 6 equal to 0. And then for every number, for every number that comes after 6, we make them equal to 0, except if the number is 7. We make I go 1 forward, because otherwise it's going to just repeat that again. And then we break this for loop, so we go back into this loop. Yeah, I think that's true. And after we do that, we just return the sum of the numbers. Geez. Double equal. What? What have I done wrong? What have I done wrong here? Is it this? No. What? What's wrong here? No. I don't see what's wrong here. This should work. Oh no, I see what's wrong. Okay, that's supposed to be a range, not. Yeah, that's supposed to be a range, not just in that. Okay. Yeah, this is the answer. Yeah, sorry that took a bit, but yeah, that's the answer. We'll go on to the next one. This should be the last one in list 2. Given an array has 22. Given an array of int, return true if the array contains a 2 next to a 2 somewhere. So yeah, I'll give you guys a little bit to solve this one. Won't give you too much time, but yeah. Okay, we'll start going over this one. So for this one, first we start with a for loop. Oops, I forgot the end. So for I in range of the length of the array -1, you'll see why that's important in a bit. Oops. But for now, we'll go on if we'll check here if this specific part of the array is equal to 2, 2. So basically, we're checking if a specific portion of the array is equal to 2, 2. And if it is, then we just return true. And otherwise, we return false. And the reason why we have a -1 here is because if we were to check for I to I plus 2 on the last number, there's no I plus 2 or there's no I plus 1 after the end. So it will just return an error. So the reason why we're doing -1 is because we're checking over here instead of over, and we're checking over here, we're checking over here, checking over here, we're checking over here, but we're not checking over here because number one, we can't have a 2 after the end, and also it would just return error. What have I done wrong? I forgot a parentheses. That's what I did wrong. Yeah. So that's the last one that we have for list. If you guys have any questions about any of the
Okay. Hey guys, so I'm gonna be going over the HackerRank problems for today. I just want to make sure, does everyone here have, or are you guys able to access HackerRank? Because obviously I can show the I can show the problems on my screen, but I just want to make sure you guys can read them on your own. So if you could let me know in the chat. Okay. So I'll go over how to create an account on HackerRank. So it's actually very easy. So basically, what HackerRank is it's an online platform that allows you to practice your coding skills, and they have a ranking system. And so basically, you start out with a really really low rank. So it would be like, I don't know, like 100,000, right? And then as you solve more problems, the ranking goes up. So it's kind of like a competitive platform. So we're going to be practicing the Python problems here. And so what you want to do is you want to click the big green button that says sign up. And then you're going to click I'm here to practice and prepare. And then create account. And I apologize as my Wi-Fi isn't the best, but as you can see, I'm already logged in. But once you click that, button, this one, then it should ask you for your email address and password and all of that. So in the question and answer channel, once you guys have created your accounts, please let me know so I can move on to at least get a few problems done today. And please let me know if you guys have any trouble creating your accounts. Um, so Cecilia, yeah, as long as you have an account, that should be fine. You don't really need to worry about what the homepage is going to look like. Just as long as you have an account set up, that's all that matters. So yeah, you're good. And everyone else, please let me know when you guys have created your accounts. Actually, let me just check if you can access the problem page without an account. Okay. Yeah, so it looks like you can access the problems without having an account. So for the students, since we're kind of low on time, just please make an account when you guys have time. And I guess we can start on the first problem. So these problems are kind of similar to coding bat, but also a little bit different. Um, so let's look at this problem. So given an integer n, perform the following conditional actions. So all that means is that we're given an int n, right? And then we need to do some tasks. And so if n is odd, we print weird. If n is even and in the inclusive, right? So inclusive means that it includes whatever range it's in. So it's 2 to 5. So the numbers that it's in would be 2, 3, 4, and 5. So if it's 2, 3, 4, or 5, we print weird. If n is even and in the inclusive range of 6 to 20, we print weird. If n is even and greater than 20, then we'll print not weird. And so what HackerRank does is it gives you your task, right? So the different parts of the problem are highlighted. They're in bold. So you're given the task, right, which is like basically just the instructions. You're given the input format, which just shows how your input is going to be given to you so that you know how to write your code accordingly. And then it's going to show the constraints, right? So we're given n, right? And in this case, n will be anywhere from 1 to 100, right? So it won't be less than 1 and it won't be greater than 100, right? And then for the output, we're only printing weird or not weird. We're not doing anything else. That's what this says. And so let's look at the sample input here. We're given 3, right? So let's go through our conditions. If n is odd, print weird. Okay. So since the rest of these are even, right? I know that this number is automatically going to be. And then so obviously the whole point of this, as you can tell, is to use the if or else statements. And basically, if you look here, you can tell that you can first, I guess, separate the conditions into two categories, odd or even, right? So let me actually open the this, and then so basically, right, we're given the integer n, and so let's first check for odd or even, right? Because we can just categorize these statements into odd or even first, and then we can go into the specifics like the ranges here, right? So if n mod 2 equals 1, right? And so remember that the modulus, all it does is it just finds the remainder. So it's if n divided by 2, if the remainder of that is 1, right? So just remember when odd numbers are divided by 2, right? They have a remainder of 1. So that's why we're using this. And so if the number is odd, right, we're automatically just going to print weird. And capitalization is important, so it's going to be weird. And just for the sake of time, I'm just going to be completing the problem and just giving you guys the solution and just walking you guys through it. And then here we can see that now we're moving into the, I guess we're moving into the even part of the problem, right? So everything here is just going to be like else. So else, right? And the reason why I put else is just because obviously like we're checking here if it's odd, so else would mean that the number is automatically even, right? And so else if n is greater than or equal to 2 and n is less than or equal to 5, right? We're going to print not weird. Okay. And we're just, you can think of it as we're just translating this into code. And so we're going to do that for this one and this one as well. So if n is greater than or equal to 6 and n is less than or equal to 20, remember we're doing the greater than or equal to and less than or equal to because it's an inclusive range. And here we're going to print weird, right? Just as the problem says. And so they're just basically giving us what we need to write. And all we're doing here is we're just translating it into code. And then, oh yeah, I can zoom in. Yes. And so let's move on to the final one, right? The final condition here. And so what that says is it says if n is even and greater than 20, right? So we're going in the even section here, and then we're gonna see if it's greater than 20. So if n is greater than 20. And remember, we don't use an equal sign here because it just says greater than 20. It doesn't say greater than or equal to. So if n is greater than 20, we print not weird, right? And then we can run our code. If we click the run code button here, what it does is it runs the code against the sample input that we're given. And so as you can see, our sample input passed and it gave the correct answer. Now we click the submit button, which will run it against way more cases, right? And so it looks like our code worked. And so this is the solution to the if else problem. And does anyone have any questions? Okay, if no one has any questions, that's it for today, I believe. And I will hand it back to the host.
Yeah. So if yeah, so if anyone you guys don't have any questions, then